This video contains 5 past questions that have been set on falling objects and terminal velocity in the last few years in physics GCSE. Each question is just written down with blanks, and then that is followed by a commentary going through that question. You'll then get question 2, and that follows the same sort of procedure. So what you could do is look through the first question, pause the video, have a go at it, and then listen to the commentary, see how you did. And the idea here is to refine your answering technique. It does include one question which is a 6-mark question, and this is quite a common one at GCSE. Shows you how to go through that with planning, having a look at the specifics of that question, and how you can structure a 6-mark question. So we're being asked for the 2 forces here, one upwards, one downwards. So the downward force here is Y, so that will be the weight of the skydiver, and then the upward force will be the air resistance, which is acting against the skydiver. You could express that in terms of drag, or you could call it friction with the air. So any of those answers would be okay. We've been asked, first of all, explain why force X acts in an upward direction. Now you should know for here that friction as a force always acts in the opposite direction to the motion. So that would go for a car, it would go for a skydiver, whatever. Friction is always in the opposite direction to the motion. Just to explain that a little bit more, the person is falling through the air, therefore the air molecules are being pushed out of the way sideways, and that creates that force in the opposite direction to the weight of the skydiver. At first, forces X and Y are unbalanced. Which of the forces will be greater? Well, it will clearly be Y is going to be greater when you first start falling. And how does this unbalanced force affect the skydiver? Well, it means that their speed will increase, which means that we could also say that they accelerate. So the skydiver accelerates, and then the other important thing is to add there in what direction do they accelerate. So speed increases downwards. Okay, so those points should be made there. So here we're being told about the parachute having opened, and after a while forces X and Y are balanced. Now that is going to be a very important statement in here, because we know that if the forces are balanced, in other words there's no resultant force, then the speed will not change and there'll be no acceleration. So we'll come to that in a moment. We're being asked what's happened to force X. Now force X is the air resistance here, upwards. What has happened to that? Well, that has increased to slow the motion of the skydiver. Force Y. Now force Y is the weight. There is no reason at all to say that the weight will have changed at all. So if he hasn't got any extra mass, he hasn't got any less mass, so this has changed Not at all, so it stayed the same. And then finally we come to this here, the speed of the skydiver will. And this is where we come back to this, balance forces, which means that the speed will not change. That also will stay the same. And that one there, a lot of people get wrong. And they either choose one or the other. So it's the speed will stay the same. Okay, this is a distance time graph. And on a distance time graph, you should have learnt that the gradient of a distance time graph gives you the velocity. Now we've got three sections here. This part is curved. BC is also curved, but from C to D, that is a straight line. And so if we're looking for the gradient, meaning the velocity, there in that section there from C to D, the gradient isn't changing. So in that, the speed isn't changing either. So we are looking to say for that one there, that the speed is not changing from C to D. What distance does the skydiver fall at a constant speed? Well, they're starting here. This is where they start at their constant speed. So that is 500. And this is where they're finishing at their constant speed. So that's at 0. So the distance they've fallen there at the constant speed is 500. And we should mention there that that is going to be meters. Don't forget to put the unit in. How long does he fall at this speed? Well, let's have a look. It gets the start at C there, and the time there is 30 seconds, and here the time is 80 seconds. So we've gone 10, 20, 30, 40, 50 seconds, and that is our time at that speed. So that's 50 seconds. There. And finally, calculate this speed. Well, we know that speed is distance divided by time. Distance over time. And we've got that. And if we do that, the distance we've already worked out in part 2. So the distance there is going to be 500. We're going to have that divided by 50, and so that will give us 500 divided by 50 is 10 meters per second. So that's our speed. Now in this situation we've got a ball bearing falling through a tube of oil. So in the other questions in this video, you're falling through air. Here we're falling through oil. Now both of those in physics are regarded as fluids, and so they will act in exactly the same way. If you're falling through a fluid, be that oil, water or air, then you will reach a terminal velocity after a while because of the balance of the weight of the object and the frictional forces. So here we've got forces here, L and M, acting on the ball bearing. What causes force L? Well, that is the gravitational attraction of the ball bearing by the Earth. You could say it will be the weight of the object of the ball bearing. That would also get you the mark. But strictly speaking, if you're asked what causes that force, it's the gravitational attraction of the ball bearing by the Earth. So from the graph here we can see that if the gradient is the velocity, then we're starting with a slight gradient here, and then the gradient gets steeper and steeper and steeper here. Okay, so we can see that the velocity is getting greater. This section here, which is straight, that means we've got a constant velocity through that bit, and in this section here where it's curved, that means the object is accelerating. We're being asked to explain in terms of the forces L and M why the ball bearing accelerates at first but then falls at a constant speed. Now the way you need to be doing this is you need to do it in 3 sections. You do the first section saying at first, and then the next section starts with later on, and then finally you'd put something like eventually. Now in this situation we can actually say when the eventually is. So we can look at the straight line section of the graph, and the straight line settles down after about 5 seconds. So we can actually add that there after 5 seconds. Okay, so what happens at first? Well, at first the force of gravity on the object is greater than the force of friction against it. So it means L is greater than M. So at first the weight is greater than the resistance, or let's say the friction here, friction of the oil. There is a resultant force downwards. So the ball bearing accelerates downwards. Now later on, as the ball bearing moves faster and faster, the frictional forces increase. Now this is because it's pushing more molecules of oil out of the way at a greater and greater rate, and that causes a greater amount of friction. So later on, the force of friction increase because the speed of the ball bearing is increasing. Now we've still got a resultant force. There is still a resultant force downwards. Right, but it's smaller. Right, which means we have a smaller acceleration downwards. So the rule is large resultant force, large acceleration, small resultant force, smaller acceleration. Now eventually, and we're saying that's after 5 seconds, the frictional force, which is M, is equal to the weight, which is L. We say now the resultant force is now 0. So the object does not accelerate. Okay, now it's quite a lot to write, but you are being offered 3 marks here. So the 3 marks are for the 3 points in your story there, at first, later on, eventually. So first of all, we're being asked what name is given to the constant speed reached by the falling ball bearing. And that is just straightforward memory recall. That is your terminal velocity, and writing that will gain you 1 mark. Secondly, you're being asked to calculate the constant speed reached by the ball bearing. Show clearly how you use the graph to work out your answer. Now in the graph there we said the constant speed is this straight line section here, and in order to work out a speed we're going to have a distance, we're going to have to work out a time, and it's essential that you learn how to show clearly how you use a graph. So what we'll do is we'll zoom in on the graph like so, and we'll try and get our distance and our time. Now the examiners usually put some convenient points on the graph, not always, but this does make things easier in many cases. So I've had a quick check on this graph, and I've found that if I go up at 5 seconds there to my graph, go up to the curve, and then from that point I go across to the y-axis like so, I find that I've now got a distance of 0.3 meters. So 5 seconds it's gone 0.3 meters. If I now then go on to 7 seconds, so that's 2 seconds later, go up to the graph again like so, and then across from the graph like that, you'll find conveniently it comes out at 0.6. As I say, it's not always the case, but I just found checking it that makes things very, very straightforward. So I now have a time 2 seconds, and I now have a distance 0.1, 0.2, 0.3. So I've got a distance of 0.3 and I've got a time of 2. So I can now write down my working here. So that's the distance equals 0.3 meters. My time is going to be 2 seconds. I would then write down my velocity or speed, it's being asked for here, equals distance divided by the time, and I then insert my numbers. So the speed is the 0.3 divided by 2, and then I work that out on my calculator. I'm working out half of 0.3, which is 0.15, and I'm making sure I put in my unit meters per second. So the examiner will be expecting to see those lines on the graph, and if they don't see them, you probably won't get one of those working marks, because you are being asked specifically show clearly how you use the graph. Right, the arrows are said to represent the size and direction of forces on a space shuttle, fuel tank and booster rockets 1 second after the launch. The longer the arrow, the bigger the force. So you have a quick look here. We've got a thrust force here upwards, and we've got here a weight force downwards. And you can see clearly that that force there, the thrust force, is much greater than the weight of the shuttle. Okay, so first of all we've got describe the upward motion of the space shuttle 1 second after launch, and because we've got resultant force upwards, that means we're going to have an acceleration upwards. So we accelerate upwards. Okay, so that's your first part there. Now they will want to see both of those, accelerate upwards. By the time it moves out of the Earth's atmosphere, the total weight's gone down because you've burnt all that fuel, and the air resistance has gone down because you're into thinner and thinner atmosphere. How does this change the motion of the space shuttle? Assume the thrust force does not change. Well, if the thrust force stays the same and this force gradually decreases, that means that the resultant is going to be even greater upwards, which means you're going to accelerate even more upwards. So we're going to put down that will be an even greater acceleration upwards. Now it's only 1 mark, so we're not being asked to explain that. Right, so that will be all that will be required of you. So we're told here the space shuttle takes 9 minutes to reach its orbital velocity of 8,100 meters per second. And we're being asked first of all to write down the equation that links acceleration, change in velocity and time taken. Now you will have learnt the acceleration equation in some form or other, but when you do a question like this, I think it's fairly important that you use the same terms that they've used in the question. So you would write that acceleration is the change in velocity, which you can see here, divided by the time taken, which is what you can see here. Then it asks us to calculate the average acceleration of the space shuttle during the first 9 minutes of its flight. Show clearly how you work out your answer. Now when you've learnt your equation, you'll know the acceleration is in meters per second squared, so that's there, which means that your change of velocity's got to be in meters per second. I've got that here, 8,100 meters per second, divided by the time taken, which has got to be in seconds. So the first thing I need to do here is I need to change my minutes into seconds. Very, very important you do that. So I go 9 minutes, so I go time equals 9 minutes, and then I put maybe equals 9 times 60 seconds, which comes to 540 seconds. Now my velocity, it's 8,100, that's its orbital velocity. When it started it was 0, so it's gone from 0 to 8,100. So my change in velocity is going to be 8,100 meters per second. And I would like to encourage you to actually do this, to write down what you know from the question so that you won't make any mistakes there. So then you're going to go acceleration will equal the velocity change, which is 8,100 divided by your 540 seconds, and when you do that on your calculator you will end up with 15, and the units will be meters per second squared. And then finally it asks you, how is the velocity of an object different from the speed of an object? Well, you'll have learnt this, I'm sure. So you'll be saying that velocity is a vector quantity. It has magnitude. Now if you forget that word in the exam, you'd say size, and direction. Speed is a scalar quantity. It has magnitude only. Once you've read through this question, you'll see that it's asking for you to work out the average acceleration during a particular period of time. So in order to work out an acceleration, you will have learnt the equation, so that's there. So you're going to need a change in velocity, you're going to need a time taken. So where you show your working, you start off by writing down your change in velocity, and that is from 50 meters per second. That's the speed at the start, and then we open our parachute and then it's only 10 meters per second. So we've gone from 50 to 10. So we're going to write down the end speed, which is 10. We're going to take away the initial speed, which is 50, and then that will give us minus 40. And that is your change in your velocity. It's minus 40 meters per second, and it's minus because you have slowed down. We then consider the time. So the time equals, the time taken for that was after 5 seconds, she's going to steady speed, going at that. So we've got 5 seconds there. So applying our thing there, we've got acceleration is change of velocity, which we've written down is minus 40. And then we've got to divide that by the time taken, which is 5. Okay, so that gives us an acceleration there of minus 8, because it's 8 fives is 40 meters per second squared. So it's supposed to, for part B, explain as fully as we can 2 things here. First of all, why the skydiver eventually reaches a steady speed. That would be the terminal velocity. And secondly, to explain why the skydiver's steady speed is lower when her parachute is open. So we know that we've got 2 forces that we've got to talk about here. We've got to talk about the weight of the skydiver, which is downwards, and the upwards frictional force of the air resistance. So we've already practiced how to do this first one here, why we eventually reach a steady speed. So this is where I've advised you to do your at first, later and eventually. The 3 statements there. We've got 3 marks, so that's probably what they're going to be for. So at first, the weight, the downwards force of weight is much greater than the upwards force of air resistance. So there is a resultant force. I should say there is a large resultant force downwards, so there is a large acceleration downwards. Alright, so then we've got our later the upward force increases. Don't need to go into extreme detail here. So the resultant is smaller, so the acceleration is smaller. And then we get to the eventually, which is really what the crux of the question's about. So we're talking about why we've got a steady speed. So eventually the downwards weight force equals the upward air resistance. So the resultant is 0, so there is no acceleration, so the velocity, it's talking about speed on this one, so the speed remains steady. Okay, why is the skydiver's steady speed lower when her parachute is open? Well, there you're going to be saying that the area of the parachute causes a larger amount of air to be pushed out of the way, resulting in more upward air resistance. Okay. Finally, we've got there the skydiver and the equipment have a total mass of 75 kilos. Calculate the gravitational force. Now, you will probably have learnt the equation to do with this, but you will probably have in your mind that weight is gravitational field strength times the mass. Right, now we're being asked for the gravitational force, which is the same as the weight. So once you've got that, you've got you know that the gravitational field strength approximates at 10, and you know you've given the mass in the question, so we've got 10 multiplied by your 75, which equals your 750 newtons. So we have parachutist, mass of 75 kilos. You're asked to work out the weight of the parachutist, showing clearly how you work out your answer, give the unit, and you're told gravitational field strength. So you will have learnt that the weight of something is equal to the mass multiplied by the gravitational field strength. So that then gives you everything you need. So you'd get a mark for quoting that. You then put in your numbers. So my mass is 75 kilos. My gravitational field strength is 10. That gives me a total of 750, and my unit is newtons. Now this is a 6-mark question, and it does require some planning. First part of your planning is to analyse the question carefully. So let's have a look what we're being asked. It's first of all, I'm being asked to use the idea of forces. So I'm going to have to write a bit about the forces that are going on here. Now I know that there's two forces, that's the forces of weight and air resistance. So that's what I've got to talk about there. I've then got to explain why and why. So I've got two bits to explain. First of all, why the parachutist reaches a terminal velocity. So that's like I can write a number 1 on there. This is just to help me focus there. So number 1, explain why the parachutist reaches terminal velocity. And then number 2, I've then got why opening the parachute reduces the terminal velocity. So I need to first of all do a bit on forces. I need to then do number 1. I then need to do number 2. Now that's now given me structure to my answer. So I'm going to get going on this now. So I'm going to start off with the forces. So a parachutist will experience two forces as they fall. First, there is the weight of the parachutist, and secondly, let's say the down which acts downwards, and secondly the air resistance acting upwards. So there I've started off by talking about my two forces, and so now I've said which direction they're going in, and I'm now ready to go into number 1. Explain why the parachutist reaches a terminal velocity. So I'm going to do a bit of my at first, then, eventually, but I'm going to tailor it to the particular question, explain why the parachutist reaches a terminal velocity. So I've really got to talk about here, why does the air resistance force increase as we fall? So I'm going to say at first, the downward force of weight is much larger than the air resistance. So the resultant, so there is a large downward resultant force, meaning a large downward acceleration. Now I'm going to go into why the air resistance increases. So as the speed increases, sorry, we're just looking on the question there, this one's talking about velocity. As the velocity increases, the air is pushed out of the way at a higher rate. This increases the air resistance. This decreases the downward resultant force, meaning the acceleration decreases. Now I'm going to go to my eventually. Eventually the air resistance is equal to the weight and the resultant force is 0. The parachutist now falls at a constant speed called terminal velocity. Right, so second one, why opening the parachute reduces the terminal velocity. So opening the parachute exposes a large surface area for air resistance. The upward force is therefore much greater we can say the parachutist will slow down, let's say decelerate, will decelerate to a new lower terminal velocity when the weight is equal to the new larger air resistance force. And that would do. We've got a hypothesis here that the larger the area of a parachute, the slower the parachutist falls. And we're told here how this was going to be tested. The height that the students dropped the parachute from was a control variable. Name one other control variable in the experiment, where the most obvious of those would be the mass of plasticine. As obviously if the mass is greater, that's then going to affect your balance of forces, and there'll be another variable affecting the experiment. The students use the student's hypothesis to predict which one will hit the ground first and give a reason for your answer. While they've hypothesized the larger the area, the slower the parachutist falls. So this one here, C, has got the smallest area, and therefore that will fall most quickly according to the hypothesis. So we would select C, and then we would say C has the smallest area, meaning that air resistance would be lowest, meaning it would fall with a greater terminal velocity. Now that last bit there may well be more than you would have written, but I would say get that little bit of detail down, that little bit of extra detail. Mention terminal velocity, mention the air resistance. Don't just say it's got the smallest area.